The next type of channel we're going to look at is a circular channel, or a pipe that's not completely full and there's a flow of water through it. So the important thing is to know how to calculate the perimeter, the wetted perimeter, and also the cross-sectional area. So as we can see here, the formula for the area of the water in the channel can be calculated using the symbol theta, which is an angle which is linked to the total depth of the water. So our area is equal to d squared, which is the diameter squared over 8, multiplied by, open brackets, theta minus sine theta. Make sure that you use theta in radians in this particular formula. So what we have to do is figure out what that angle theta is, and then we can substitute it into that formula and work out the area. The perimeter is pi d. Pi d would be the total perimeter of a circle times the fraction of the angle that is taken up by theta divided by 360. So it's theta over 360. And then we have a discharge Q, and that is using the Manning formula, which is the Manning formula, which is actually velocity multiplied by A. So we get A over N times hydraulic radius to the 2/3 times the square root of I. Right, let's have a look at an example. We're asked to calculate the discharge for the following circular channel. It has a diameter of 500 millimeters. The slope is 1 in 800. The Manning constant is 0,012, and the pipe is half full. Right, so let's have a look at the area. The area is d over 8 times theta minus sine theta. So what is theta? If our pipe is half full, and that is the center, then theta is actually 180 degrees. So we have 180 pi over 180. In other words, we're converting it into radians. Pi over 180 would be the radians. We then subtract sine 180 pi over 180 gives us an area of 0,09817 square meters, but it is half full. The perimeter is pi times 0,5, which is the diameter, pi d, times the fraction of the angle. So that would be 180 over 360, which is actually a half. And that gives us an answer of 0,7854 meters. Our mean hydraulic radius is area of perimeter. And we've worked out both. So we have 0,09817 divided by 0,7854, giving us a value of 0,12499. Discharge, using the Manning formula, we said it's A over N, mean hydraulic radius to the power 2/3 to times the square root of I. So So if we substitute, we've got the area 0,09817, and we have the Manning constant 0,012, mean hydraulic radius 0,12499 to the power 2/3 times the square root of 1/800, which is our I value, and therefore our discharge is 0,0723 cubic meters per second, and that is when the pipe is half full at an angle of 1 in